Okay, I think this is probably a good time to start. It looks like quite a few folks have joined us. Sheena, are you good?
Yeah, everything looks good here to me.
Sheena? Okay, good. Well, with that, I just wanted to say welcome and good morning to everyone, and welcome to the July webinar in the Best Practice series sponsored by DataKinetics. My name is Leah Manzoor, and I'm the VP of Sales for DataKinetics, and I'll be your host this morning. So today in the webinar, we're going to address upgrading your current data replication solution, whether it's for DB2, IMS, or vSAM. So we're going to focus on the mainframe being a component, whether it's a target or a source for data replication, and then we'll also discuss open systems or the cloud being targets as well. So before I start, I just want to thank everybody in advance for sharing a part of their morning with us, and we're delighted that you've joined us today. So as we go through the presentation, if you have any questions, we encourage you to go ahead and log it in the question box, and we'll address the questions at the end of the presentation. So our agenda today consists of giving you a quick introduction to DataKinetics, what we do as a company and who some of our customers are and how they use our technology. Then we'll discuss upgrade considerations. So maybe you want to replace a single-purpose replication product, or maybe your business now requires an integrated solution, or you need new functionality like near real-time latency. We'll also talk about the need for high availability, change data capture, event publishing, and audit history tracking in the common replication scenario section. Then we'll review replication architecture. And then lastly, we'll discuss the conversion process, defining the different activities that you're going to encounter during a conversion, and recommend some success factors for you. So a little bit about DataKinetics. So we were founded in 1977. So we've been solving IT problems and reducing IT costs for the proverbial who's who of corporate America. And we have a dedicated team of technical and service folks that have pretty much focused on delivering enterprise solutions to the most challenging issues that a lot of data centers in the Fortune 500 have experienced. So we're a leader in data access optimization, and our products address application performance optimization using in-memory processing. We optimize data movement and integration, and we optimize database performance as well. So we're a privately held company, and our headquarters is in Ottawa, Canada, and we have regional offices throughout the U.S. We're also a long-standing IBM business partner, and we have an international set of customers across the Global 500. So as you can see, about 20% of the Fortune 50 currently use DataKinetic products. And this includes 3 of the top 5 banks, credit card processors, and U.S. property and casualty insurance companies. As well, we have the top 2 largest healthcare insurance companies in the U.S. So as you can see, we have the largest and the second largest companies in these primary vertical markets. And these are all long-term customers. We've been working with these folks for a combined total of over 1,000 years. And we've had 100% retention rate of our customer base. And we've actually lived to talk about it. So you probably heard of some of our customers. They're the virtual cornucopia of blue chip companies. And these companies don't trust just anyone with their most mission critical business applications for optimizations. And we've enabled the top data centers in the world to overcome today's challenges. And these challenges include like data access, performance and capacity, and we power over 1 billion mission-critical transactions every second of every day. So some of the use cases that these companies use our technology for is fraud detection and alerting, consolidated financial statement processing, loyalty program detection with rules on the fly and in real time, enablement of big data analytics for BI and cloud migration, and of course the maintenance of those older legacy applications. So we save these customers billions of dollars every year. And we do that by reducing the cost of transaction processing and many times accelerating processing up to 98% faster, which is no small feat. So we reduce the cost of data movement, we reduce the cost of DB2 data access, and we can save significant money on OpEx spend and eliminate CapEx spend as well. So now I'd like to introduce Scott Quillisi, who's the CEO of SQ Data out of Irving, Texas. And SQ Data is a partner of DataKinetics, and they've pretty much built their technology around the best practices that Scott's going to be talking about today. And some of these best practices are enjoyed by such companies as Bank of America, Bell Helicopter, and AT&T. So with that said, I'd like to give a hearty welcome to Scott.
Thanks, Leo. Appreciate that. And I'd like to thank everybody for joining this morning. As Leah mentioned, the focus will be really on best practices and what to look for in a replication tool when you plan to upgrade. There are a lot of replication tools out there, a lot of older replication tools. And at some point, you're looking at upgrading, whether it's the current release of what you have or newer technology. So, as far as us, SQ Data, it's a single product that operates using change data capture technology. That's really our secret sauce. We also do ETL, the traditional ETL, for full loads, but people look at us really for high performance, near real-time change data capture technology that really drives a lot of solutions downstream. It's not a single-purpose product. It is a multi-purpose product. It runs on a variety of platforms and flexible, easy to deploy and maintain, and it's usually less costly than the competition to acquire and operate. As far as, like I mentioned, the single tool that addresses a lot of different things, transformation, business intelligence, fraud detection, continuous availability, active-active setups are becoming more common. We'll talk about that later. Basically the sky's the limit as far as data integration goes. It all centers around the ability to capture changes as they occur. And we're talking within, a few milliseconds. So why are companies upgrading? We've actually enjoyed quite a run over the last 5 or 6 years of replacing older single-purpose replication products. And what I mean by that is some of these legacy replication products, I'm not going to name vendors, but I think everybody knows who they are, do one thing and they do it okay. But companies are requiring additional capabilities more than just straight replication. They need something that can do event publishing, heterogeneous without buying a lot of extra software, data warehouse populating big data repositories. And they need this near real time. Sometimes a second is too long. In some of our customers, acceptable latency is 100 milliseconds. Anything over that is you might as well measure with a calendar. So near real time, very fast, and low overhead. So as far as success factors in tool selection, the tool you select for your upgrade, or if you don't have a replication product, something to consider for your solution, would be to provide capabilities outside of straight replication. The traditional, the source and the targets match fairly close, if not identical, and that's all it does. It has to have a way to do consistency checking and rematerialization without purchasing additional software. There's a vendor out there, it runs primarily on distributed. They have a consistency checker, but they charge for it, and it's not cheap. Our case is why charge separately, and that's just not not in our DNA. It should have built-in custom conflict detection resolution. Should not require multiple products. Needs to be able to run on multiple platforms, and it has to be able to work and play well with other data integration products. As far as the conversion really should be vendor assisted. You must be able to complete this rapidly with minimal personnel. It shouldn't take years to upgrade. It should take, I don't know, a matter of weeks to actually do the upgrade itself, and then validation becomes the key factor, where you must have a validation plan, and it's smooth. It should be a fairly seamless conversion, and we've gone through these many times, so we understand best practices in how to actually do an upgrade. As far as ongoing operation, it should be fast, reliable, easy to maintain, be able to handle volume spikes. And we're talking extreme volume spikes. Normally what happens is batch cycles tend to spike volume. We see this where it's at night. You might see an arrival rate of 20, 30,000 transactions or updates a second, sometimes more. Sometimes we see with one particular customer that we're replicating about 500 million updates a day. 30% of that comes in 4 hours. So you have to be able to handle the spikes and then just fall back to normal operation. And last but not least is the better it folds into your existing processes, the better. I mean, it really needs to do that. We've seen other products where you're tied to a separate GUI. It's not part of your existing version control. So if you want to make changes, you actually have to go through your normal version control to upgrade the app or the table structures, and then you get to go to the GUI and do it by hand. It introduces all sorts of possible errors, and it just slows things down. It's not what we'd recommend. Now, how is replication being used today? With our customers, over half are using it to populate a data warehouse or a business intelligence type application. That's probably slimming down a little bit, although I'm going to classify the big data repository population in the same thing as business intelligence. We're seeing more and more of that with larger companies. It used to be small companies. Now the bigger companies are embracing Hadoop, Cassandra, and some of the big data repositories. So that's more and more becoming a target. Event publishing is another thing that a lot of people use it for. They want to know if a customer status changes near real time. They want to know, for example, a healthcare company, if a claim is submitted for over $500,000. They want to know about that immediately, at least a fraud app does. We're seeing 14-15% in high availability space, where for disaster recovery or the more advanced customers are using active-active, where they have 2 data centers live, split the workload across the country, and replicating both ways. That's becoming more and more common versus active-passive, which is just one-way replication for DR. And then a few are using it for audit to find out who changed data when, sensitive data, and to what. So at this point, let's take a look at some common replication scenarios. High availability or continuous availability is, again, a big play for replication where the sources and targets are identical. You have the traditional active-passive or active standby. Now, you'll notice in our slides we have IMS and we have DB2, but you could certainly plug in Oracle, SQL Server, vSAN, MySQL in these boxes. Replication isn't confined to one particular database type. But active-passive, again, takes an exact copy from a source, puts it into a DR site normally or a standby in case something happens and they can switch over. Active-active, on the other hand, as I mentioned, is becoming more and more accepted by the bigger companies where they're running multiple data centers, multiple copies of the data, versus having a separate DR site some of these companies that have multiple data centers are choosing not to have the DR site, instead rely on their own infrastructure in case of failure. So active-active presents a different set of challenges. We have a separate best practices on that. But you can see why you'd need near real-time capture for both sides, and latency has to be very, very low to keep things as current as possible. This slide, active-active with selecting routing, just gives you an idea of what you can do with the right replication tool. If, for example, you're going active-active, say with DB2 in this case, and you want to be able to, while you're capturing this data, spin off other data, certain data versus, for example, a table with a certain column value, greater than 500, for example. You might want to spin off to a warehouse. You might want to spin all the updates for a particular table or tables to a data warehouse or an event publishing framework. So once you capture, there's a lot of things you can do with it. You can keep it in the active-active realm, or you can or send it downstream to other places to be used, so you don't have to run multiple captures. CDC enhanced ETL. We see this mostly for data warehouse population to appliance type technology like Netezza, or what I call Netezza, it's called something else now, Teradata, Greenplum, where you're populating a data warehouse or business intelligence application, but they don't necessarily want near real time for everything. They might want staged applies. So when you're looking at replication tools, you want a product that can update near real time and stage the changes to be used for existing ETL process to pick up. Normally there's a lot of logic built into these ETL processes. They've been around for close to 20 years. Customers typically don't want to reinvent the wheel, so the ability to stage the changes and let the existing processes pick up saves time and money. Another feature you want to make sure your replication tool has is an event publishing capability. And what this normally is capturing changes, analyzing those changes, and publishing XML messages or JSON messages. We're seeing more and more of that, but typically it's XML that ends up in one or more downstream applications. So near real time, for example, the claim submitted over $500,000. Fraud sees that within half a second normally. Now history, this is actually something that we would use to stage for CDC enhanced ETL, or where you want to track who's changing what table and when and what they actually changed. So normally what you have are some what we call staging attributes, the time of the change op. You want to make sure you can capture the user ID, the table qualifier, and so on, and then the columns you want. But again, it all centers around near real-time change data capture. So in summary, you really want to make sure that the product you select has the ability to do all of the above. Okay, we're going to spend a few minutes talking about replication basics. Really 4 primary components. A lot of products only have 3, the first 3, but you have normally a source capture. You have to transport the data in a lot of cases and apply it on the target side. So you got source data capture, data transport, target apply, and then the 4th piece is something that we feel, as part of best practices, needs to be included in the product suite, is a consistency checker to make sure your source and target are in sync. In replication, that's something that can happen, is you can get out of sync. You have to have the ability to detect that, and this is really a peace of mind. Okay, as far as data transport, what you'll see out there are 2 primary methods. Queues, like JMS queues or MQ series queues, and TCP/IP, native. Queues has its advantages. It manages transient storage of the change data in addition to the transport fairly reliable, very predictable, can handle, I say high data volume. I would probably back that down to moderate to high. It's kind of expensive. It does add an extra part to the mix, and it struggles with large units of work. Large units of work are really, really not good with queues. Replication in general, large units of work, is one of the challenges. But if you put queues in the mix, you're adding CPU time, significant. You're adding latency and overall cost to ZOS environment, for example. Native TCP/IP, on the other hand, is much faster and more efficient than queues. It's very fast. We basically have the ability to take and eliminate the overhead associated with queue managers. It handles extremely high data volumes, reduces the number of moving parts, and of course, lower CPU. But the product you pick for upgrade should be able to handle both. Should be able to use queues or native TCP/IP. You should have a choice. Lower volume replication, queues are fine. The high volume, critical, we would recommend native IP. All right. As far as capture, IMS data capture, we'll start here. It's similar to other databases, but you've got data capture exit routines you can use. You can use log-based capture, application-based, and hardware replication. I'm not going to go through each one of these in detail. We could always take some of these offline, but database exit routines are somewhat like triggers, not really, but close. They don't require any application changes. And the big thing with this is it doesn't require the hex 99 log records, which is a huge, huge inhibitor for large IMS shops. When you turn on change data capture in the logging for IMS against FastPath databases, you're looking at doubling your log output. Some people are already archiving every 3 or 4 minutes. You add the 99s and they're down to a minute and a half. These are huge, huge logs, talking 1,000+ cylinders. So serves a purpose. Log-based, on the other hand, is good for customers that don't have a certain environment or moderate volume. It works very similar to the way DB2 would work, where we actually read the log, get the 99s, and replicate those. Near real-time latency is pretty close. You can also run asynchronous with this, and we have customers that do both. So just a little bit on capture methods for IMS. This slide is a picture of high-performance IMS replication, and again, your tool you pick should have more than one method of replicating IMS specifically. In this case, we're using data capture. We store the transient transactions in a coupling facility log stream, or 2 or 3, or in one case, 8, depending on the volume and the degree of parallelism you're looking for. It goes to a CDC store publisher that publishes changes downstream to the apply engines that end up in the target. The log piece is, again, for customers that have 99 records that they want to capture from the logs. So you need a product that can read from multiple IMSs at the same time. We're assuming data sharing across multiple LPARs, say 4-way, 5-way data sharing. Organizing each one of those to make sure the transactions are in order, and then the publisher framework down using native TCP/IP remains the same as any of the other captures, which is important. For best practices, you don't want a product that does things differently between databases. The architecture should be solid and very similar across all environments. So even if you're using SQL Server replication or Oracle replication, the framework needs to be the same. Okay. Now, DB2-based log replication, what we see are 3 primary categories. Log analyzers, I call it the poor man's method. Log analyzers are great. They do a lot more than just replication or capture of change data, but it's really not full function. It typically just replays SQL. If you're looking for anything that above and beyond that, it takes a lot of customization, and for event publishing, good luck. Conflict detection becomes a real challenge with this. It's just not full function. It wasn't really designed that way, but some of the vendors make you think it is. If it works for you, fine. But if you need something multidimensional, then you need to look at an upgrade. Then you have your single-purpose data replication products that typically are homogeneous. For example, DB2 to DB2, or if you're going, say, DB2 to Oracle, you require additional products. Unacceptable, in my opinion. You should have one product that does everything without requiring product B, C, D, and E. And then you have your multi-dimensional data integration products, which SQData happens to be one of those. There are some of these out here. The key attributes are heterogeneous, so relational and non-relational support, going from relational to non-relational, going from, say, DB2 to Oracle or Oracle to IMS, vSAM to Oracle, and so on. Needs to be done with these multidimensional products. Needs to be able to do ETL, which is bulk loads, replication near real time, event publishing, and then general data integration. So a multidimensional product is what you're looking for. As far as DB2, a lot of the products out there, and you may have these in-house already, use, well, this is probably the worst case. It's against an older product that's been around for closing in on 20 years that stages changes in DB2. So it captures changes and stages those in DB2, and then you have multiple agents that read those staging tables and then replicate downstream via event publishing or something. But normally in this particular product's case is straight replication. The overhead is astounding with this. So if you think about it, the application updated table or tables updates more tables, staging tables. The subscriptions or the applies actually go and pull that data from the staging tables. Then you have to delete the data. It is extremely expensive, and most of the modern or newer technology for replication eliminate all this, and we've seen savings in minimum 50% CPU over time, and that is quite a bit of money. That's hundreds of thousands of dollars to some folks in a month. The optimal replication tool setup is to minimize the impact on DB2. That's key. So lose the control tables, lose the staging tables. Don't beat up any DB2 any more than you have to. In our case, all we do is grab log data through the IFCID 306 interface. Most commercial DB2 replication products use this, if not all. If they don't, then I would question even using them. It's a supported API. Make sure they run the IFCID 306 as the interface. The capture, again, lightweight publishing to a publisher. You kind of want to decouple those guys, if possible. And then have the ability to go to queues or straight IP to multiple apply engines on multiple platforms. So you could have one capture and 5 or 6 applies, maybe more, on a variety of platforms like Linux, Windows, Unix, and so on, even ZOS. So now that you've determined you need to upgrade, what's involved? I mean, selecting a product, you got that done. Now you're looking at a conversion. So the success factors for conversion is to automate as much as possible. Really, 90+% is desirable. For straight replication, it could be 99, 100%. Dramatically reduces the conversion timeline. You want, for straight replication, it could be less than a week, even for 5,000 tables, if it comes down to it. We happen to have a lot of automated conversion tools because we do this a lot. We upgrade a lot of the old data replication tools with SQData. So you want to automate as much as possible. You don't want this to be a manual process. Resource availability. It's critical that we have access to DBAs and systems programmers when needed. Security, typically up front, security is critical to make sure that the authorizations are set and so on. And then most important are application to subject matter experts or access to application folks that know the way the application behaves. They know any kind of special transformations outside of straight replication, why it's there, what it accomplishes. And so we see that DBA, security, systems folks get involved early. The application SMEs get involved later, all the way through validation. So you want to, for validation, if you can, leverage the vendor's replication consistency checker. There's no reason you can't have run a side-by-side, and that's usually what happens, and run a tool to actually do the compares versus having somebody sit down and write SQL. That's not necessary. And it should require minimal personnel. This is the longest part of the process is the validation, and so the fewer people, the better. And then as far as vendor support, make sure your vendor actually knows what replication is. It's not just a product. In our case, that's what we do, so we think we're pretty good at it. We've been doing it for, coming up on 15 years now. Timely assistance with configuration, operations, special enhancements, and so on. You want a vendor that actually partners with you in the conversion to make it successful. All right, as far as conversion activity, once you identify the source and target tables of interest, it's usually already defined in the existing replication setup, but it may include additional tables that were planned to be part of the existing tool but never made it. Then you want to install and configure the tool itself. Create the source to target mappings. Again, automated is better. Manual is usually required for business logic, any kind of special processing, filters, and so on. Then you want to deploy and run parallel, creating a shadow set of replicated targets so you can compare against what you're currently running. And what most people do is those shadow targets, when they decide to go production, they just switch the shadow targets to real and turn off the old one. So it serves two purposes. Validation, again, the vendor's consistency checker saves a lot of time. You have to make sure that the results are correct. Now, one thing that's interesting is when you go through the validation, initially you'll find things, especially if it's not straight replication, you'll find things that weren't properly coded, or certain business logic wasn't coded correctly, so or data types weren't being handled properly. Mostly with IMS, actually. Once those are fixed, then we find that the errors are a result of the tool you've been running for the last 15 years, providing incorrect results. So that just encourages people to cut over to the new tool sooner. But it's not a real complicated thing. It just needs to be fleshed out and managed, set expectations, and so on. Okay, as far as verifying source to target consistency, I've said this, I beat it up. It's very important. So in our case, again, we include our consistency checker with the product. It's not a separate product, and it shouldn't be for best practices. It's intended for 24/7, 365. We assume most customers run that way, always up, high volume. You need to be able to support multiple databases, IMS and relational, checking the source and target during active replication. So it has to be able to do this while the data is moving at a high rate of speed. The days of shutting everything down to quiesce mode to run compares are gone, long gone. These systems stay up all the time, and so the consistency checker has to be able to run with a very active system. And this particular checker works with or without our replication suite. So if you wanted to buy it separate, you can. But yeah, I would say just really needs to be included in the product suite. Okay, to summarize, and we're right on time, Leah. You'd be proud of me. Tool evaluation and selection. Make sure your tool meets your current and anticipated future business requirements. You want to be able to do it with one product, not multiple products. So it's like, well, we're doing replication, we're going to use product A. We're doing event publishing, let's use product B. We're populating Hadoop, let's use product C. Now, make sure that the tool you pick can handle all of them. As far as ZOS, limited choices available. You might have 3 or 4 in the world that can handle everything, if that. So choose carefully. The operation needs to be efficient, reliable, and not chew up all your CPU. Actually reduce it if you're upgrading. And again, fit into existing processes like version control, change management is paramount. Again, conversion, the automation, the more the better. Keep it short, get that part done, and then move on to validation. Again, the best way is to use a consistency checker. You can write your own SQL. We have customers that do both. And it's got to be performed with minimal personnel. You don't want to have to allocate a full team. It should be done with a part-timer if possible, because a human resource is expensive in most customers, and they're allocated to other projects. So a part-timer should be able to do this. And then again, the vendor. Make sure your vendor has experience with data replication. The nuances with business event publishing. I've been there, done that type of thing, avoiding common mistakes. And then the vendor must also be able to provide a quick turnaround on customer-specific enhancements. And we get those a lot. Customers say, it'd really be nice if we could do this. So we'll take a look and usually create a new function or something like that and turn it around in a fairly short order. So it's not like you have to wait 2 years. You can get it within a month or so, typically. At this point, I think we can throw it open to questions, Leah.
Yeah, that's great. Thanks, Scott. A lot of good information there. Okay, we have a couple of questions. The first question is, what type of performance benchmarks have you seen with your product over IBM's Data Propagator?
Okay, now we're mentioning products. Data Propagator is the old 20-year-old product that I was referring to earlier with the staging tables. That is, we see a lot of interest in upgrading from that. Now, the customer has a choice, to stick with the IBM products, which they still have dprop, but it's called SQL replication now. Not really state-of-the-art because of the staging tables. It's extremely expensive. But to answer your question, 50% overall CPU can be saved. And then latency goes from, say, 4 or 5 minutes to near real time, sub-second.
Okay, great. Okay, I have another question here, and it's actually a multi-pronged question. Have you had cases where customers want to take data from IMS, DB2, or VSAM and move it into Hadoop? And what challenges have you seen? And can you share mainframe metadata with Hadoop?
That's a good question. That's actually might be a follow-on. But yes, we're seeing more and more of that. We've seen today most of the data that ends up in Hadoop or any of the other variants is relational. It's still structured in some manner. It's not, unstructured data. We have had some interest non-relational data, IMS specifically, but I imagine VSAM's right behind it, that they want to go to Hadoop as well in a structured format. Now, Hadoop's a little different. in that you really don't do updates. It's an insert-delete type of thing. So if you're doing an update, you can specify it as an update, but under the covers it's really doing a delete insert of something new if it exists already. But that should be transparent to the customer. The challenges was that, understanding for us, how the big data repositories handled updates. Deletes are simple, inserts are simple. Updates required a little more thought. And then how they want to store it. As far as sharing the metadata, yes, I think you can. We haven't, I'd have to talk to my guys about how they do that. But normally the metadata would consist of strictly the structures itself, just how the data is structured, field 1, 2, 3, 4, what they mean, and so on. Similar to what you get from a COBOL copybook or DDO. It's not extensive, but we'd be glad to talk to them offline about details of metadata. Metadata is a whole different can of worms, whole different beast. Required, absolutely essential, and you want to make sure that you don't have copies everywhere. You kind of want to have the version of the truth in one place.
Great. Okay. Next question. Outside of your product, is there any additional software required to replicate mainframe DB2 data to Oracle?
To answer your question, no. No, everything's pulled in our product. Everything comes out of the box. You don't require, I'm not going to point fingers at other products, but normally there's a gateway you'd have to buy, or a different publisher if you're going from, say, DB2 to Oracle. Not required with us. Everything comes out of the box. No extra products.
Okay, great. Next question. What would be the concerns as to the execution of the data capture on USS for System Z OS DB2 replication?
Oh, that's a good question. I don't really have major concerns on that. Our stuff runs native ZOS. We do use a lot of USS services because our product does run on multi-platforms, and it has a kind of a Unix flavor to it. It's not a terrible implementation. It's a little harder to monitor with traditional monitoring tools like BMC Patrol or MainView, or not MainView, but the actual monitoring products and alerts. A little more difficult there than it is. We also see that USS skills are decent out there. Some customers are better than others, but you probably want a hybrid. As far as whether it's running general purpose processor or not, it's still on the GPs, for the capture side. So not to really summarize that, not a lot of concern, but it's a matter of preference.
Okay, good. Well, we're right at the 11:45 mark, and we pretty much guaranteed that we'd be done in 45 minutes. But there's a few more questions, and we'll be happy to reply via email to the folks that asked those questions. And I just wanted to tell everyone and thank them for their time today. And we understand that everyone's time is precious, and we hope that we were able to give you some insight into some data replication best practices, and hopefully you've gained a little bit of knowledge from our presentation today. So if you have any comments or suggestions for future webinars, we'd love to hear them. You can forward any suggestions to sales@dkl.com. Again, sales@dkl.com. And with that, I wish to thank Scott from SQ Data, and I want to wish everybody a great day, and we hope to see you on another DataKinetics webinar in our best practice series in the future. Thanks again.